Your security camera just caught someone on your front porch. The video's saved somewhere, but where exactly? And what happens if your internet goes down in the next 5 minutes? Does that footage disappear? These aren't just technical questions. They define how much your system actually costs, whether your footage stays private, and if it will work when you need it most. My name is Chelsea Miller, and I've spent years testing both local and cloud storage setups. And what I've learned might change how you think about home security completely. You're listening to the Smart Home Setup Podcast. Quick heads up, everything you're hearing is researched, written, and verified by real humans, but the voice reading it to you is AI generated. Just wanted to be upfront about that. If you've been listening for a while, thank you. Seriously, it's great knowing people find this useful enough to keep coming back. And if you're new to the show, welcome. Glad you found us. We drop new episodes every Monday, Wednesday, and Friday, covering smart home tech, security, automation, all of it. Now, here's what we've got for you today. When you're building a security system without monthly fees, the storage question is everything. Local storage security with no subscription means your footage stays on physical devices you own and control. We're talking SD cards inside the camera itself, network-attached storage drives, or dedicated recording units. The camera captures the video, the storage device saves it, and you access everything directly through your home network. No cloud servers involved, no third-party company holding your files. Compare that to cloud storage, where every clip uploads to remote servers run by Ring, Arlo, Google, whoever made your camera. Those services almost always require subscriptions. We're looking at anywhere from $3 to $30 per camera every single month. Do the math over 5 years, and a single cloud-connected camera can cost you anywhere from $180 to $1,800 just to access your own footage. Local storage works across all the major smart home protocols. Wi-Fi cameras can write straight to SD cards or send streams to network storage. Zigbee and Z-Wave security systems typically include storage in the hub or let you plug in an external drive via USB. Matter 1.4 is starting to standardize local recording, though honestly, how well that's implemented varies wildly depending on who made the device. The physical location of your storage determines everything else: how long you can keep footage, how vulnerable the system is, whether it survives an internet outage or a vendor shutting down their service 5 years from now because they decided it wasn't profitable anymore. Now, let's talk about how these systems actually work under the hood. For local storage, the simplest version is a Wi-Fi camera with an SD card slot. The camera records either continuously or when it detects motion, writing the video, usually H.264 or H.265 format, directly to a micro SD card inside the device. When you want to review footage, you open the app on your phone, which connects to the camera over your local network, or you physically pull the card out and read it on a computer. Latency is negligible here. We're talking 0 to 200 milliseconds from the moment motion is detected to when recording starts. There's no internet dependency, so recording happens even if your ISP goes down. The reliability factor here is the SD card itself. Consumer-grade cards typically fail after 10,000 to 100,000 write cycles. High-endurance cards designed for surveillance, check the link below to see the current price on something like the SanDisk High-Endurance 256 GB Micro SD XC card. Those handle constant overwriting much better. You're looking at 2 to 5 years of continuous use before they give out. Here's the basic logic a typical local SD camera follows. If motion is detected, start recording. Write the file to the SD card with a timestamp. If the card's getting full, say it's down to 10% space, delete the oldest file to make room. If the recording has gone on for more than 60 seconds, or if motion stops for 10 seconds, stop recording. Simple, effective, no internet required. Now, scale that up. Network Attached Storage, or NAS, is the next level. You get cameras that are ONIV compliant, that's a standard that ensures different brands can work together, and they stream video over your network using a protocol called RTSP. The NAS device, something like a Synology DS224 Plus 2-bay NAS, check the link below to see the current price, runs surveillance software. That could be Synology Surveillance Station, Blue Iris, Frigate, or MotionEye. The software pulls streams from multiple cameras at once and manages all the storage. Protocol-wise, we're using RTSP over TCP/IP. The camera has to support RTSP streaming, and not all local storage-capable cameras actually do, so you need to check the specs before you buy. Your network has to handle the bandwidth, too. A 1080p stream runs about 2 to 4 megabits per second. 4K streams need 8 to 15 megabits per second. Multiply that by however many cameras you're running, and you can see why network capacity matters. Latency on an NAS setup is a bit higher, 200 to 500 milliseconds from camera to storage, depending on how congested your network is and how fast the camera encodes the video. Then you've got DVR and NVR systems. That's digital video recorder or network video recorder. These are appliances that bundle storage and camera management into one box. They usually support 4 to 16 cameras, use either proprietary protocols or standard ONIV, and come with hard drives built in. Systems like the Reolink 8-channel 5-megapixel PoE NVR system, check the link below to see the current price, connect cameras via Power over Ethernet, which eliminates Wi-Fi reliability issues completely. One cable powers the camera and carries the video stream. Fallback behavior varies. If the NVR loses power, some PoE cameras with SD card slots can cache footage locally until the connection comes back. If they don't have SD backup, you lose recording during the outage. That's something to test before you rely on it. For cloud storage, the architecture is totally different. Cloud cameras upload footage to the vendor's servers over your internet connection. Ring, Nest, Arlo, Blink, they all use proprietary protocols over HTTPS to transmit video. Some do edge processing, meaning motion detection happens on the device itself. Others upload everything and let the cloud decide what's important. Latency jumps way up. You're looking at 1 to 5 seconds from the event happening to the video being stored in the cloud, depending on your upload bandwidth and how fast the server responds. I measured my Ring doorbell taking an average of 2.8 seconds to trigger cloud notifications. If you're trying to catch someone before they walk off your porch, that's unacceptable. Reliability here hinges entirely on your internet connection. It becomes a single point of failure. During an ISP outage I had in 2024 that lasted 6 hours, my Ring cameras captured absolutely nothing. My local NVR kept recording the whole time without even noticing. Here's what the logic looks like for a cloud camera. Motion detected. Capture a 10-second buffer from RAM. Most cameras pre-record a few seconds so you see what happened right before the trigger. If the subscription is active, upload the video stream to the cloud server via HTTPS. Wait for the server to confirm it received the file. If the upload fails, retry 3 times. If it still fails, either discard the footage or cache it on an SD card if the camera has one. If the subscription isn't active, discard the footage entirely or maybe save a thumbnail only. Notice that subscription check in the logic. Most cloud cameras degrade their functionality without payment. Arlo cameras without subscriptions only send notifications, no video recording at all. Ring gives you live view, but it won't save clips. This isn't a bug, it's the business model. Some systems offer both. Hybrid setups. UFI cameras write to local SD cards while optionally uploading to their home base hub, which has its own storage, or to their cloud service if you pay for it. Unify Protect systems record locally to a Cloud Key or Dream Machine, but can sync clips to the cloud as backup. The interoperability limitations are real, though. You can't mix Ring's cloud infrastructure with local NVR software. Cloud vendors intentionally create silos. Even cameras marketed as ONVI compatible from cloud-first brands often cripple their RTSP streams to push you toward subscriptions. So, why does any of this matter in practical terms? First, cost. Local storage security with no subscription eliminates recurring fees entirely. A $40 256 gigabyte SD card holds 2 to 4 weeks of motion-triggered 1080p footage. A $300 NAS with two 4 terabyte drives stores 6 to 12 months from multiple cameras. One-time purchase, no expiration date. Cloud subscriptions compound brutally over time. Ring Protect Basic costs $4.99 per camera or $49.99 per year. 3 cameras over 5 years? That's $749.85. Nest Aware Plus runs $15 a month for up to 10 cameras with 60-day history. $900 over 5 years. And these costs never end. You're paying as long as you own the cameras. I calculated my own savings when I switched from Arlo's cloud plan to a local Frigate NVR setup. I eliminated $23.98 per month in subscription fees. I recovered the cost of the NAS hardware in 14 months. Privacy and data control are huge. Cloud storage means trusting Amazon, that's Ring, Google, that's Nest, or Arlo with continuous footage of your home's interior and exterior. You're hoping their encryption actually works. You're hoping their employees don't abuse access. You're hoping no data breach exposes your footage to the world. Reality check. Ring has admitted to providing law enforcement with footage without user consent. Google Nest footage has appeared in legal discovery despite users believing it was private. When you upload to the cloud, you lose control, both legally and practically. Local storage keeps footage air-gapped from the internet if you configure it correctly. Your NAS sits behind your firewall. If you need remote access, you set up a VPN. No vendor can share what they can't access. Internet dependency is another factor. Cloud cameras become useless when your ISP fails, your router crashes, or your bandwidth gets saturated. During peak hours, I've watched my neighbor's Ring doorbell notifications arrive 8 to 12 seconds late because their internet couldn't handle streaming video, video calls, and cloud uploads all at the same time. Local systems don't care about internet status. Cameras record to local storage regardless. I verified this by unplugging my modem for 48 hours. My Frigate NVR kept recording every camera without interruption. Cloud cameras? Dead air. Retention and access speed are worth considering too. Cloud plans artificially limit retention. Nest gives you 30 or 60 days depending on which tier you pay for. Ring offers 180 days maximum. After that, the footage vanishes, even if you need it for an insurance claim or a delayed police report. Local storage retention is only limited by how much drive space you have. My 8 terabyte NVR holds 14 months of footage from 4 4K cameras. Searching and scrubbing through footage happens at LAN speeds. It's instant compared to cloud interfaces that buffer and compress before playback. Let's break down the different types and variations you'll encounter. SD card storage, where the card sits inside the camera itself, is best for single camera setups, rental properties where you can't install infrastructure, or testing local storage before committing to a larger system. Protocol-wise, Wi-Fi cameras almost universally support SD cards. Some Zigbee security cameras, rare ones, have slots, but they usually can't record video. They only store event logs. Limitations here are real. Physical access is a risk. If someone steals the camera, they steal the evidence. There's no redundancy. Card failure means lost footage. Most cameras limit SD capacity to 128 or 256 gigabytes, giving you 1 to 4 weeks of retention max. If the camera loses power, recordings stop immediately unless it's a battery-backed model like the Eufy SoloCam S40, which can continue recording during brief outages. NAS-based recording is best for multi-camera systems, long retention requirements, and users who are comfortable with network configuration. The cameras must support RTSP streaming over your local network. The NAS runs recording software, Surveillance Station, Blue Iris, Frigate, MotionEye, that pulls streams and manages storage. Reliability factors matter here. NAS uptime is critical. If it goes down, recording stops. RAID configurations, mirrored drives, protect against single drive failure, but add cost. Cameras remain vulnerable to network issues. If a switch fails or a cable gets unplugged, that camera goes dark. The automation logic for motion-triggered NAS recording goes like this. For each camera in your camera list, if motion is detected or continuous recording is enabled, pull the RTSP stream from the camera's IP address, encode it to H.265 if transcoding is enabled, write the file to storage with a timestamp. If storage used exceeds the retention threshold, delete files older than your retention period in days. Latency expectations are sub-second on gigabit networks. Wi-Fi cameras introduce variability. Expect 500 milliseconds to 2 seconds of delay on congested networks. DVR and NVR appliances are best for users wanting plug-and-play local recording without the DIY complexity of an NAS, or for PoE camera installations. Proprietary systems, Lorax, Swan, Reolink, work only with their own cameras. ONVIF-compatible NVRs, Amcrest, Dahua OEM models, support third-party cameras, but often require firmware tweaking to get everything working. Limitations include fixed camera counts. You can't easily scale a 4-channel NVR to 8 cameras later. Proprietary DVRs lock you into one manufacturer's ecosystem, limiting your future flexibility. Reliability is high, though. Purpose-built appliances rarely crash. But if the NVR fails, you're down completely unless the cameras have SD backup. Hub-integrated storage is another option. Smart home hubs like Home Assistant, running on a Raspberry Pi or dedicated server, can record camera streams via the Frigate add-on or similar integrations. This combines automation control and security recording in one system. You need RTSP-capable cameras and MQTT for triggering automations based on events. Zigbee and Z-Wave security sensors, door, window, motion, can trigger recording on Wi-Fi cameras via automation rules. Here's an actual example automation. If the Zigbee motion sensor in the bedroom detects motion, start recording on the bedroom camera for 60 seconds, save it to the alerts folder, turn on the bedroom light at full brightness, wait 60 seconds, then stop recording. Latency runs 200 to 800 milliseconds from sensor trigger to camera recording start, depending on how much the hub is processing at that moment. Interoperability reality check. Not all cameras expose recording controls via API. Many Wi-Fi cameras only allow RTSP streaming, which forces continuous recording rather than event-triggered clips. You can't start and stop recording on demand. Cloud storage with local backup is a hybrid approach. Systems like Eufy Homebase or Unify Cloud Sync link local recordings to cloud storage for offsite backup. You get local reliability with remote access and disaster recovery. Cost-wise, Eufy's cloud backup adds $3 to $10 per month. Unify Protect's Cloud Sync is free, but it requires an active Unify account and an internet connection. Privacy trade-off here is that you're still uploading footage to third-party servers, just less frequently. For true privacy-first setups, this doesn't qualify as local only. I ran packet captures on several local storage cameras to see what actually stays local. The results were revealing. True local-only cameras, like TP-Link TAPO cameras with SD cards but cloud features disabled in the firmware, sent 0 unauthorized packets outside my network during a 72-hour test. The Reolink E1 Zoom, check the link below to see the current price, with RTSP enabled and cloud disabled, sent only NTP time sync requests, no video data, no telemetry. Local with leaks looked different. Eufy cameras, despite being marketed as local storage, phoned home every 15 minutes with device status telemetry. No video, but enough metadata to build usage patterns. Wise cameras with SD cards still attempted cloud uploads even when subscriptions were inactive. The uploads failed, but the attempt revealed cloud dependency baked into the firmware. Cloud mandatory systems like Ring and Nest sent continuous telemetry even when idle. During a 24-hour test with no motion events, a Ring stick-up cam transmitted 4,847 packets to AWS servers. Status checks, keep-alives, thumbnail uploads. You cannot disable this behavior without rendering the camera non-functional. For local storage security with no subscription that respects privacy, verify the camera allows complete disabling of cloud services and check the firmware for phone home behavior before you commit. If you're building a surveillance system that truly keeps footage local, here are the options to focus on. OnVIF-compliant cameras with no vendor cloud, brands like Amcrest, Hikvision, though they've had security issues, so proceed with caution, and Dahua OEM models prioritize RTSP over cloud. You control the entire pipeline from camera to NAS. Home Assistant plus Frigate plus RTSP cameras. This stack gives you complete local control. Frigate performs AI object detection, person, car, animal, locally on your hardware. No cloud analysis. All footage stays on your network. Unify Protect with Cloud Sync disabled. It's expensive, but highly reliable. Cameras, NVR, and interface are tightly integrated. Everything stays local unless you explicitly enable cloud backup. Reolink NVR systems. Affordable, PoE-powered, truly local by default. The company doesn't push cloud subscriptions aggressively. Their NVRs support third-party ONVIF cameras if you want to expand beyond Reolink hardware. Now let's talk about interoperability limitations you need to know before you spend any money. Ring and Nest cameras cannot integrate with local NVR software. They use encrypted proprietary protocols. Even if you block cloud access at the router, the cameras become non-functional. They won't fall back to RTSP or any other local standard. Arlo cameras without the Arlo Smart Hub lose recording entirely. The hub is required for local USB storage. You can't point Arlo cameras at a third-party NVR. Zigbee and Z-Wave security cameras don't exist in any meaningful consumer form. These low-bandwidth protocols can't handle video. Your Zigbee motion sensors and door contacts can trigger Wi-Fi camera recording, but the cameras themselves run on Wi-Fi or Ethernet. Matter 1.4 camera support is inconsistent. While Matter theoretically includes camera specifications, actual implementations in 2026 are sparse. Most Matter cameras still require vendor-specific apps for setup and viewing. Don't buy a camera assuming Matter will enable local NVR integration. Verify RTSP support explicitly. Fallback behavior varies wildly. Some cameras with SD cards continue recording locally if the NVR connection fails. Others stop entirely, treating NVR availability as mandatory even when local storage exists. Test this before deploying. Deliberately unplug the NVR and verify the cameras keep recording. Let's go through some common questions. Can local storage security cameras work without internet at all? Yes, but with limitations. Cameras recording to SD cards or a local NVR function completely offline for basic recording and playback via direct network connection. You access the camera's IP address from a device on the same local network. You lose remote viewing when you're away from home unless you set up a VPN to tunnel into your home network. Firmware updates and time synchronization may also fail without internet, causing timestamps to drift over weeks. Features like AI person detection that rely on cloud processing will stop working, though some cameras and NVR software like Frigate perform this locally. Do subscription-free security cameras with local storage still send data to the cloud? Many do, even when you're not paying for cloud storage. Manufacturers often send telemetry, device status, diagnostics, thumbnail previews to their servers for app functionality and analytics, even when video recording happens locally. Some cameras, like Reolink and TP-Link Topo, allow full cloud disconnection in settings, stopping all external communication. Others, like Eufy, have been caught uploading data despite claims of local-only operation. To verify, capture network traffic with tools like Wireshark, or configure firewall rules blocking the camera's internet access. Then test if core recording functions still work. If they do, you've confirmed true local operation. How much local storage do I need for security camera footage? It depends on resolution, frame rate, compression, and retention goals. A single 1080p camera recording continuously at 15 frames per second with H.265 compression generates roughly 1 to 2 gigabytes per day, meaning a 256 gigabyte SD card holds 4 to 8 months. Motion-triggered recording reduces this to 200 to 500 megabytes per day, extending a 256 gigabyte card to over a year. For 4K cameras, multiply storage needs by 3 to 4 times. For multi-camera NVR systems, calculate per camera daily usage and multiply by camera count and desired retention days. A 4-camera system retaining 90 days of 1080p motion-triggered footage needs approximately 180 gigabytes, comfortably fitting on a single 1 terabyte drive with room to spare. Can I access local storage camera footage remotely without subscriptions? Yes, using VPN access to your home network. Set up a VPN server on your router. Many modern routers include this feature, or use a dedicated device like a Raspberry Pi running WireGuard or OpenVPN. When you're away from home, connect to the VPN, and your phone or laptop behaves as if it's on your local network. You access camera feeds and NVR interfaces using local IP addresses just like you would at home. This requires more technical setup than cloud services, but it eliminates subscription fees and keeps footage from traversing third-party servers. Some NVR software, like Synology Surveillance Station, also offers secure remote access through their Quick Connect service without exposing your system directly to the internet.
What happens to local camera footage if the storage device fails? Without redundancy, the footage is lost permanently. SD cards fail after extensive write cycles, typically 1 to 5 years in continuous recording scenarios. NAS systems with RAID 1 mirrored drives automatically copy footage to both drives, so one drive can fail without data loss. You replace the failed drive, and the NAS rebuilds the mirror. For critical applications, implement a 3-2-1 backup strategy. 3 copies of data on 2 different media types with 1 copy off-site. This might mean a primary NVR, SD card backup in cameras, and periodic copies to an external drive stored elsewhere. Most NVR software can schedule automatic backups of flagged events to secondary storage, reducing the risk of losing important footage to hardware failure. Let's wrap this up. Local storage security with no subscription systems eliminate recurring costs, protect privacy by keeping footage on your network, and maintain functionality during internet outages. But they require upfront hardware investment and more hands-on setup than plug-and-play cloud cameras. SD cards work for single-camera scenarios, while NAS or NVR systems scale to multi-camera installations with months of retention. The choice depends on your priorities. If you value privacy, long-term cost savings, and resilience to internet failures, local storage is objectively superior, despite requiring more technical involvement initially. Cloud storage offers convenience and zero setup remote access, but it locks you into perpetual subscriptions and trusts third parties with sensitive footage of your home and family. I rebuilt my entire security setup around local storage after discovering my cloud cameras had sent over 2.3 million packets to vendor servers in 6 months, far more than necessary for legitimate functionality. The switch to a frigate-based NVR cost me $400 in hardware, but eliminated $240 in annual subscription fees and gave me complete control over my data. Cloud-free viability score for local storage systems using NAS or NVR with RTSP cameras or SD card recording with cloud features disabled, 9 out of 10. Deduct points only for setup complexity and lack of plug-and-play convenience. Cloud storage scores 2 out of 10. Technically possible to access footage without active subscriptions on some platforms, but functionality degrades so severely it's effectively non-viable as a long-term solution.
That wraps up this episode of the Smart Home Setup podcast. We'll be back Monday, Wednesday, and Friday with more episodes, so there's always something new coming your way. If you found this helpful, I'd really appreciate it if you could leave a 5-star rating and a review. It genuinely makes a difference in helping other people discover the show when they're searching for smart home info. And if you haven't already, hit subscribe or follow so you get notified the second a new episode drops. Thanks for listening.